Advanced Algebra, Chapter 7, Lesson 3, and we want to wrap up this lesson by looking at dividing these binomial radical expressions. And much like we divided radical expressions where there wasn't really a division algorithm or process going on, we were simply simplifying the fraction, and then if we needed to, we multiplied the numerator and denominator by a radical expression that caused the denominator to become a rational number, thus rationalizing the denominator. We're going to pretty much do the same thing when we're looking at these binomial radical expressions when we're asked to divide them. When we're dividing these binomial radical expressions, we're going to need to rationalize the denominator in much the same way as we rationalized the denominator before. And what we need to do then is to multiply this denominator by something that will cause this denominator to no longer have an irrational number in it, but to have just a rational number. And you remember from our discussion in the previous lesson, when we were multiplying conjugates of these binomial radical expressions, that multiplication of conjugates always produced a rational number. So we're going to use that knowledge then to apply that to the division. And so in order to rationalize this denominator with a binomial expression, we're going to multiply the numerator and the denominator by the conjugate of this denominator. That is going to give us a rational number in the denominator, which is what I want. And that really is division of these binomial radical expressions. Is another way to say it is to just simply rationalize the denominator of these expressions. So in the example here, I have 1 minus the square root of 5 in the denominator, so the conjugate of that would be 1 plus the square root of 5. And because it's a fraction, I need to multiply numerator and denominator by the same expression. So multiplying these conjugates in the denominator will produce a rational number in the denominator, and then I simply multiply the numerator and simplify the expression. So the rationalization process would look something like this, where I'm multiplying numerator and denominator by the same binomial expression, which is the conjugate of the denominator. The multiplication process produces a rational number in the denominator, and then the simplified in the numerator looks like this. Now I'm going to want to simplify this expression, and to simplify this we're going to need to split this expression into the two fractions. You remember when I have a plus sign in the middle of the numerator with a single denominator, I can write this as two fractions. So I can take the 8 over the negative 4 plus the 4 square root of 5 over the negative 4, which then allows me to do some more simplifying. So this simplifies to negative 2. These 4's reduce to a negative 1. So the simplified version then is negative 2 minus the square root of 5. So the process or the concept, I think, is fairly simple. In order to divide these binomial radical expressions, we're going to multiply numerator and denominator by the conjugate of the denominator, and then we're going to simply make sure we do that to numerator and denominator, and then everything else from there is just a matter of multiplying using the distributive property and then simplifying these fractions. Okay, I'll do a few examples here at the end so you can watch those and help you walk through a few of those, and then we'll wrap this video up. So for our first example, we have 5 plus square root of 3 over 2 minus square root of 3. So in order to divide this, we simply want to rationalize the denominator. So in order to rationalize the denominator, we're going to multiply by the conjugate. So the conjugate of this would be 2 plus square root of 3. So I'm going to multiply the numerator by the exact same value. Now, you remember in my denominator, I'm multiplying conjugates, so the shortcut is simply I can square the 2, which is 4. I can square the radical 3, which is 3, and then a minus sign in between. Now, for the numerator, I'm going to use the distributive property, so I'm going to multiply the 5 times 2 plus square root of 3, and then I'm going to multiply the positive square root of 3 times 2 plus the square root of 3, and that's going to be my numerator. So 5 times 2 is 10, and 5 times square root of 3 is 5 square root of 3. Then this would be 2 square root of 3, and then square root of 3 times square root of 3 is 3. So then I can add the like terms, so I have 13, and then these are like radicals, so I can add those together, so that's plus 7 square root of 3. And then I can go ahead and simplify this further. So I have 13 plus 7 square root of 3. 4 minus 3 is over 1, so both of these are over 1, so this would be my final answer. And we can go back here and check it out and see if we have the right answer. And we do have 13 plus 7 square root of 3 is my correct answer. So if we take 3 plus square root of 8 divided by 2 minus 2 square root of 8, let's take a look at that one. When I'm looking at this problem, we could begin by multiplying by the conjugate and just jumping right into that, which would be okay. But I'm a big believer in simplifying before we do anything, because it can create smaller values for me to work with, or we've seen in the past that rationalizing or simplifying before we rationalize removes the need to rationalize, or at the very least we simplify at the beginning. That makes the simplification at the end of the problem not necessarily, or again at least maybe eliminates a step or two. So I like to simplify at the beginning whenever I can. I notice that the square root of 8, I know that from previous work that can simplify to, if I do its prime factorization, to 2 square root of 2. So rather than having this 2 square root of 8, I have 2 times, and then I have the simplified version of square root of 8, which is 2 square root of 2. So this becomes 4 square root of 2. So my denominator then is 2 minus 4 square root of 2. I also have a square root of 8 in the numerator, which again simplifies to 2 square root of 2. Now, the simplification process here does not eliminate the need to rationalize, but it may help simplify some things now that I might have to do at the end. So I'm going to multiply by the conjugate, both my numerator and denominator. Remember that because I'm multiplying conjugates, I can do the shortcut in the denominator. So the 2 squared is 4. The 4 radical 2 squared is I square the 4, and I square the radical 2. So that gives me 32, and I put a minus sign in between. For the numerator, I'm simply going to distribute. So I have the 3 times the conjugate, 4 square root of 2, and then I have the 2 square root of 2 times the conjugate. 4 square root of 2. So then we distribute. So this is 6 and then 12 square root of 2. This becomes 4 square root of 2. And then now I have the 2 times the 4, which is 8. And the radical 2 times the radical 2, which is 2. So this is actually 16. So then I add my like terms. I have 16 and 6, which is 22, and then the 12 and the 4 radical 2, which is 16 radical 2. So my numerator is 22 plus 16 square root of 2. When I add the denominator together, I then get 22 plus 16 square root of 2 over negative 28. I now want to split this into its 2 fractions, so that's 22 over negative 28. Plus, and then I have 16 square root of 2 over negative 28. And then I can simplify each one of these. So dividing both of these by 2, I get negative 11 over 14. And then now this is plus, and because one of these is negative, this entire fraction is negative. So plus a negative means negative. And then both of these are divisible by 4, so that becomes 4, and that becomes a 7. So I have minus 4 square root of 2 over 7. So this would be the division of this binomial radical expression divided by another binomial radical expression. Okay, so again, there's nothing, I don't think, overly complicated about what we're doing. The advanced algebra aspect of this is, in order to divide these binomial radical expressions, we simply multiply numerator and denominator by the conjugate of the denominator. Everything else after that is just an application of the mathematical arithmetic skills that we already know. Distributive property, and then adding like terms.